Good morning, 你好. Welcome to Blockchain and the Lindy Chen channel. My name is Lindy Chen. I'm very excited to be here and share my insight about blockchain with you. Yesterday, I shared with you relevance and the roles of intermediary and utilized blockchain to facilitate disintermediation. Today, I will share with you technical limitation of the blockchain. Introduction. It is important to recognize that blockchain is an emerging technology and that is constantly evolving. This section will discuss some of the limitations that could restrict the application of this technology. As with the advent of the Internet and the World Wide Web, the expectation is that innovation for application will quickly follow. With that said, the section will highlight some current issues to be considered and overcome. Technical limitation of the blockchain. The key things to remember is that blockchain is a peer-to-peer system that allows peer to read the transaction history, add new transaction data to the blockchain, rely on its decentralized nature of control and openness for consensus. With this in mind, consider the following potential limitation possible due to the technical nature of the blockchain: privacy concerns, security concerns, scalability and flexibility, potential for indirect centralization. Privacy concerns. To enable nodes to participate in the blockchain, each node must have visibility over the transaction history, transaction details including the asset ownership and asset value, rules around the timing of the transaction, the transaction stakeholders including any intermediary. Without this visibility, nodes cannot verify ownership or create new blocks, and the blockchain would terminate or be rejected at that node. This strikes at the core objective of building trust where no trust exists, the premise of a trustless transaction. Historically, this has been the domain of intermediary, and this will take time to overcome and could be considered a limitation of the blockchain. Security. Consider for a moment your car or even your credit card. How many keys do you have? Your credit card has one password for you to access funds and transact, and your car only accepts one key to open and start it. We have discussed how blockchain uses cryptography to achieve two goals: to identify accounts, to authorize a transaction. The concern here revolves around the possibility to decrypt these keys or even the hash tags or hashed function. Private keys can be inadvertently passed to someone or lost in the same way a set of car key could, or your credit card PIN. Consider a symmetric cryptography is considered to be the strongest cryptographic method available. The use of a combination of private and public key offers extraordinary security. Consider this compared to currently acceptable PIN system locks utilized to authorize mainstream transactions where ownership cannot be easily confirmed. Regardless, there are some who consider the use of hashing and cryptography to be insufficient security in the application of the blockchain. Scalability and flexibility. Let's revisit two significant goals of the blockchain. 1. To protect the asset history and ownership from being manipulated or forged. 2. To allow updated data to the collective asset history. Adopters of blockchain typically require high processing speed and scalability for their application. The immutable append-only data structure and the use of hash puzzles, proof of work, to dealer and identify attacks each and every time a new block is added to the blockchain is time-consuming and requires resources. Read this as continuing time and energy. This characteristic of the blockchain is considered the biggest hurdle to adoption and application. Consider also that their security is no established procedure for updating or changing a block once it has created and set in motion. It can be argued that the blockchain is therefore set in stone forever. The immutable characteristic of the blockchain removes its flexibility also. So, in comparison to other technology, it is certainly less flexible in its ability to change and adapt once the block is verified through consensus. Potential for indirect centralization. One of the tenets of the blockchain is that it replaces a centralized authority that processes and authorizes transactions. This is accomplished through a decentralized peer-to-peer network and generally use proof to work to determine consensus, verify ownership, and process transactions. Proof of work can be a two-edged sword. On one side, it is essential for determining integrity through hash puzzle, and on the other, it creates work for the nodes in verifying the block, appending it, and creating the new block. In an ideal world, each node operates independently. However, one of the challenges already discussed is compensation. Put simply, nodes will continue to participate where the reward is greater than the cost to process the block. The cryptocurrency platform and the algorithm, commonly known as Fabric, are based on early Bitcoin blockchain fabric and are extremely resource-hungry, energy in particular. Consider, blockchain is typically being applied to enterprise transactions beyond cryptocurrencies. It was a pretty straightforward model to compensate nodes in cryptocurrency. However, as a blockchain technology is applied to other industry and application beyond cryptocurrency, the question of compensation and impact of the structure and participation of nodes become a challenge. Revisiting some characteristics of compensation model, they are acceptable as an instrument of payment beyond the application of the blockchain that generates the compensation. They have a stable value that is not at risk of losing purchasing power. They do not undermine the ability of the blockchain to create trust and credibility. They should be generated in digital format so they can be included in the blockchain transaction. As a result of this advancement in application of blockchain, the structure of and the size of decentralized network could diminish. We are already seeing aggregation of nodes into pools where they share resources and also specialized hardware and software provider, the latter giving rise to a smaller number of networks that offer specialized fabric that enables lower cost network and subsequently scalability. Giants such as IBM and Microsoft are already developing Fabric in much the same way that they provided application and infrastructure that enabled the World Wide Web over the Internet. The challenge will be to maintain the decentralized nature of the peer-to-peer network. Another dynamic with aggregation is from a geographic perspective. This is occurring in the area of cryptocurrency mining. For example, China is responsible for approximately 70% of Bitcoin hash rate. Essentially, the hash rate describes how much computing power, called hashing power in blockchain speak, is being thrown at the network by users all across the world. The implications are reflected in jurisdictional regulation, social and cultural norms. So, from a technical perspective, these systems are still a distributed system, only it is maintained by a smaller number of entities. This could be argued to be an indirect centralization. From myself, the team at China Direct Sourcing, the team at Friesen Technology, and the team at Blockchain Collective, thank you for watching this video series. If you like what you see and hear and want to know more about it, please subscribe our channel and contact us. Good luck with your blockchain learning journey. Enjoy the program.